Nanopore Diagnostics, we're developing a rapid test for diagnosing bacterial infections. The problem we're trying to solve is the lack of rapid bacterial diagnostics in the market today. Currently, it takes so long to diagnose a bacterial infection, physicians often are forced to make decisions based on symptoms alone. Something we've all experienced. You have the symptoms of an upper respiratory infection, you're not sure if it's viral or bacterial nature, if you have a cold or if you actually need an antibiotic. So you call your physician, you go see the physician, and based solely on how you feel, they either give or don't give you the drug. And that's actually an incredibly ineffective practice. It has led to 50% of all antibiotics in the US today being improperly prescribed. So 1/2 of the times you've taken antibiotics in your lifetime, you probably didn't need it. And the reason physicians act on symptoms alone is because there's no current rapid test that would allow them to know with confidence whether or not antibiotics are really needed, and then even on top of that, what kind of bacteria they were treating and which drug would be best suited for that bacteria. And so what we're developing is a rapid test that can function in a physician's office, in a hospital, right at the point of care, and in under 30 minutes allow a physician to be informed when making that antibiotic decision. Know for sure if there's bacteria there and then what kind of bacteria it is. The underlying platform that allows her rapid testing is the Immu technology. It's a nanopore-based sensor for counting target nucleic acids like pieces of DNA or RNA. And so what the sensor allows us to do is it allows us in a very complex sample to count nucleic acids specific to bad bacteria.
So with this technology, we can accurately detect genetics and epigenetic change in patient blood.
Andrew's work is a fantastic example of something that can go from the very basic level at the bench to being translated into real-world significance.
Nanopore Diagnostics aim to commercialize this technology into accurate, rapid, and low-cost pathogenetic detection tools for early cancer detection in clinical setting.
His work's not just restricted to one particular disease. We're finding that these microRNA patterns vary with particular diseases, and they also are altered during aging and development. So there's a very wide importance, and hopefully we'll be able to translate his work into many more spheres than his own particular interests.
Science is no longer just, I think, thought about from a grant perspective. What can I do to advance the field? What can I do to get the next grant? It's what can I do that's going to make a commercialized product that's both going to bring money to me and the university to fund my lab in the future. And so because of that kind of shift in thinking, there are a lot more technologies being invented, and there's a lot more creative ways that people are taking university invention and turning them into enterprises.